test for gases begin today. And we are taking stoichiometry and bringing that back. We are then bringing back Avogadro's principle. Remember, Avogadro's principle was 1 mole equals 22.4 liters at STP. And then we are also bringing back the ideal gas law, which is PV equals nRT. Or if you're solving for mass, you could do PV equals mass RT over molar mass, since mass over molar mass equals moles. So we are bringing stoichiometry back, and then we are bringing these two things along with it. Okay, so it kind of combines several different things from several different chapters. We're taking equations and we're balancing them. We're writing formulas. We got all kinds of good stuff going on. So it's almost like a rehashing of since November in here. Exciting, huh?
I'm excited.
Yeah, Sean.
Don't make fun of me, but what's stoichiometry?
That was the BCA tables, the before, change, after, where you had the clouds and the coefficients and all of that. Yes, sir.
I promised you that there's 13.2 and I did.
Okay. Can we do that at the end of class so I can record it?
I'll probably tell you about it.
All right. Okay. Well, now we have it on the recording for posterity. So, all right. So, of course, you're going to start with a balanced equation. Now, here is where I have to come clean with you. I kind of didn't tell you the entire truth when we were doing stoichiometry.
How dare you?
I know.
10 times harder.
I know. No, it's actually pretty easy today with the stoic. So remember when I said only moles in the holes? Yeah. Okay, where you could only put moles in the BCA table?
Yeah, I did that.
Well, you could actually put liters in there too. Okay?
Oh,
No, because you haven't done anything with liters yet, honey.
You lied.
Oh, well, it either has to be in moles or liters. That's the option. Okay, so it's not going to get that easier that way.
Well, guess what? I'm putting mine in.
Because I would have given you grams, and you had to go to liters, and you didn't know how to do that, and so yeah.
You should only give us liters.
Well, that's what we're going to start with today. Okay, so what we're going to do is we are going to set up our BCA table, our stoichiometry. Okay, we have propane here and propane accessories. Anybody know the cartoon that's from?
King of the Hill.
King of the Hill, yes, and Hank Hill, yes.
What? Yeah.
All right, got to start with our balanced equation. So I'm going to put a 3 here, a 4 here, and then go back and balance my oxygen out with a 5. Then it told me 4 liters of propane. So I'm going to take and I'm going to put 4 under the propane. Now let's dust off some of those cobwebs and remember how to do stoichiometry. When we have our value here, we're going to bring that up into the cloud. What mathematical process do I use going into the cloud? Division. So 4 divided by 1 is 4. Then when I come down out of the cloud, and they're asking about oxygen here, when I come down out of the cloud, what mathematical process do I use? Multiplication. So 4 times 5 is 20. And 20 liters of oxygen then is our answer. Easy enough? Remember how to do that?
Well enough to do
Good.
it. Maybe.
Actually, can we back it up to acids?
Sorry,
I spaced for a minute. I wasn't paying attention. Can we back it up to the periodic table?
Can we back it
Can we back it up to quantum notation? The Bunsen-Burner lab, please.
All right.
Can we back it up to the chapter 1?
We are making solid sulfur. So solid sulfur or sulfur, whenever you see sulfur or solid sulfur, you've got sulfur in your homework tonight. That's actually S8.
That's a lot of sulfur.
Yeah. So S8 plus oxygen is going to give us SO2. I need to balance my equation here. So this is going to be an 8, and this is going to be an 8. I am starting out with 3.5 liters of SO2, or I'm ending up with that. They want to know then how much oxygen I'm going to need. Okay. So I'm going up into the cloud. What do I do to go to the cloud? Divide, yeah. So I'm going to divide by 8. Oh, there it is. All right, so 3.5 divided by 8 is 0.4375. Then I'm going to multiply by 8, come down. That's going to be 3.5. That's liters of oxygen. That is my answer.
How much sulfur is there?
Well, if you want to do sulfur, then it would be 0.4375 liters of sulfur. But they didn't ask about that. They asked about the oxygen.
Yeah, but it didn't seem like a lot.
That S looks like a 5.
This S looks like a 5? No, get over it. All right, here we go. We've got hydrogen gas. We've got oxygen gas. And we are making water. All right. I have 5 liters of oxygen gas. And they want to know or determine volume of hydrogen gas. So I'm going to take this up into my cloud. My cloud's going to have what number in it? 5. Then I'm going to take it down. When I take it down, I do what process? Multiply. So 5 times 2 is of H2. All right. Next one, we have propane and oxygen. That's going to give us carbon dioxide and water. So see if you can follow this one. You are figuring out how many liters of this, and you're starting with 34 liters of this. See if you can figure out the answer to that. You will need a calculator probably. At some point, you will also need a periodic table. So while you're in that lovely little bag, get it out too.
Or C3H8, right?
I have the equation written up there for you. I've led the horse to water.
I was just asking which one of the things it was.
Well, you know it's not oxygen, and you know that's carbon dioxide, and that's water. So it's probably the one that's left over.
At the time, did I?
Apparently not.
Propane is obviously C3H8. If you look back at the other page, it shows
I'm not
us
looking back at the other page. I don't want to have to flip. You shouldn't have to either. No.
Pronounce that
British people don't have to.
You absolute stupid.
Why is he so formal?
And a random fluctuation of your voice. It sounds like you're trying to get
Wrong pronunciation. We're in completely different parts of
Got the answer yet, y'all?
I know what your favorite symbol favorite symbol of all time?
Numbers.
No. That's
Wow.
yeah, Skyrim symbol.
So, good job, guys. Good work, team. Good hustle.
I never said you would. Are you assuming it?
Every day. And it makes an ass out of you.
All right, good. Were you able to get the correct answer?
Yes.
Okay.
You said it makes an ass out of you.
All right, last one. We have methane. We have oxygen. We are forming CO2 and H2O. I need to balance. All right, there is my balance. I've got 2.36 here. We got to figure out what this guy is.
I mean, this is pretty advanced algebra here. I'm vomiting throwing up.
It's easy now, but let's
What did you get?
4.72.
4.72, and that's going to be liters of O2. Anybody have any trouble getting that one? That make sense?
Yeah.
Okay. All right, let's move on to something a little more advanced. I'm going to skip 6. I'm coming back. We're moving to 7. I should have renumbered these. I should have rearranged these. I want to focus on the ones that are at STP right now, okay? Because if things are at STP, that means that we're going to use Avogadro's principle.
It's an avocado.
Okay, so we're using his principle in this process. All right, so they want to know in here what the mass is. They are giving us liters of something else, and they want to know mass of ammonium nitrate. Okay, so this is not just I can slap it in here and move from place to place like we did up here. That's when you're going volume to volume. Okay, now we are going mass or volume to mass. So I'm going to start by putting my 0.1 liters in here for dinitrogen oxide. So this is my dinitrogen oxide. I'm going to make sure that my equation is balanced, which it is. And they want to know, so I've got that many liters. I'm working with liters here. So that means that I've got the same number of liters of this stuff. Good? All right. Once I know the liters of this stuff, if I'm at STP, then I can use Avogadro's principle. So 0.1 liter NH4NO3. Nice straight line. I'm going to be getting rid of liters. So I want to put liters here. And according to Avogadro's principle, at STP, I can go into moles. So for every one of these, I have 22.4 of these. Am I done? No, I need to get it into mass. How do I get moles into mass? Molecular mass, right. So I'm going to find the molecular mass of 1 mole of this. I get that off of the periodic table. And because I ended up with 80. Okay. Multiply across the top, divide by the bottom, and I end up with 0.357 grams of NH4NO3. It's not a pretty 4. Let's try that again. There. Thoughts?
Yeah.
What?
Have them.
All right. Let's look at the next one. this one, we're figuring out liters of carbon dioxide, and we're starting with kilograms of calcium carbonate. Okay? So the first thing we need to do is we need to convert kilograms to grams, and then grams to moles. And then if we're at STP, we can convert that into liters. So that's what I'm going to do with my dimensional analysis. And then that's all of the calcium carbonate. Okay. And then I'm going to use my stoich to convert from the calcium carbonate liters over to the moles. No. Liters. I'm sorry. Liters. Wait a minute. Yeah, I'm going to go to liters of carbon dioxide. Okay. So this is kind of our plan. This is what we're planning to do, just to kind of give you an idea of what we have to do for this problem. All right. Any questions about what I'm about ready to proceed on doing?
So it is at STP.
Yes, this is at STP.
All right. And wait, 1 kilogram is 1,000 grams.
Yep. Okay, so we have that little bit of information. We've got 2.38 kilograms. We're going to take kilograms into grams. Then we're going to take grams into moles. And then I'm going to take moles into liters. I'm going to fill this in. Like he said, for every one of these, I have 1,000 of these. For every one of these, I'm going to take the molecular mass of calcium carbonate, which ends up being 100.1. Oops, I put that in the wrong spot. My bad. And then for every 1 mole here, I have 22.4 liters. Okay, so I multiply across the top, divide by the bottom. What do I get? I'm rounding 533 liters, and that is going to be my calcium carbonate. So that is this 533 liters, which means I have how many liters of calcium oxide? Or, no, they were asking the CO2. It doesn't matter. It's the same thing anyway. 533 liters of CO2. And that is my answer. All right, so that was number 8. Number 9 is not at STP, so we're going to come back to that. Number 10 is at STP. So here we're calculating the volume of oxygen, but they're giving us the grams of iron. Okay, so let's talk about our process here. First thing that we're going to do is we're going to take our grams of iron and we're going to convert into moles of iron. And then we're going to take our moles of iron into liters of iron. Then we're going to use our stoich to go liters of iron into liters of oxygen. Right. Okay. Let's see if you can set that up and solve for liters of oxygen. Go. I have 4 of you on the board that I still need your lab from. I'm not going to say your names since I'm recording this.
Stop sign. Say their full names, social security numbers, addresses, birthdays, mother's maiden name.
You know my
Post this
social
on
security
YouTube.
number? I really like that.
Where they keep all your money.
Yeah. Coming
All right.
in the door.
Did you get this done, or did you start talking, Andrew, and you haven't finished it?
I am.
Where should we route it to?
Go 3 sig figs. Yeah,
For what, the amount of oxygen?
the answer. Yeah.
Uh,
So grams of iron. I'm going to go into grams into moles of iron. That's 55.8. And then I'm going to go into liters of iron. Not like that. I'm not. Moles, iron, liters, iron. And that's going to be 1 and 22.4. Okay. So I ended up with 20.87. That's liters. So 20.7. Take that up and divide it by 4.
20.9 and then you put 20.7.
20.9 and divide that by 4. And that ends up being 5.21 or 22 actually if you round. And then they wanted to know oxygen, so I'm going to take that and multiply it by 3, and that's going to give me 15.7 liters of oxygen. Okay? How much time do I have?
A lot.
Yeah, you've got time.
28? How do I get out of here? No, 40. Okay, yeah, I got time. I got 15 minutes. Okay, we're still doing good. All right, let's try one more. I want you guys to try this one on your own. I'm going to balance the equation for you. So calcium, chlorine, KCl, 2, and 2. Okay, so let's talk about our path here. We're getting liters of Cl2, and they've given us grams of potassium. So our path, we are going to go from grams of potassium to moles of potassium to liters of potassium. And then we're going to use our stoich to go liters of potassium to Cl2, because that's what they want us to get. Okay, so see if you can do your math and come up with the right answer for this guy. How'd you do? I got 2 more. You're going to watch the last part of the video, okay? You're going to watch the last part of the video. And homework tonight, due Thursday, is 13-4. Macy, did you get your lab turned in? Huh? Fine. Bring me the hard copy on.
Reaction type packet. I thought
All right. I want to keep going. I've got 2 more problems to do with you guys. I need to show you how to do these with the ideal gas law. Okay? So we're at the point now where we're out of problems that have STP. So now we're going to have to use ideal gas law. Okay? So we're going to start out. We're going to start out with our stoich. So we've got 5 liters of nitrogen. They want to know grams of ammonia. So here's our path. Number 1, we're going to use our stoich to figure out. We're going to take liters of nitrogen and we're going to go into liters of ammonia. Then I'm going to use the PV equals nRT to get moles of ammonia. And then you could, if you wanted to use that other equation, you could do that in one fell swoop with taking moles and replacing with M over MM. I prefer then to just use my dimensional analysis and go from moles to grams of NH3. I think it's easier, it's less cluttered with that equation. So that's just my preference. Again, you could do this. Remember I gave you the PV equals MRT over MM the other day? Okay. All right. So first step is to do the stoich. So I've got nitrogen. Nitrogen is going to react with hydrogen. And they're going to form NH3. All right, I've got to put a 2 here and a 3 here. I'm going to take my liters of nitrogen then, which is 5, and I'm going to figure out how many liters of NH3 I'm going to make. So what's my cloud going to be? I got to do my cloud up here because I ran out of room. 5, because 5 divided by 1 is 5. Then when I come down here, how many liters of NH3 am I going to have? 10. Okay, so that's my liters. Then I'm going to bring that in to my PV equals nRT. With PV equals nRT, what am I solving for? Which part of this am I solving for? N. I'm solving for this. Okay, so I'm going to rearrange this so N is on one side. So I'm going to divide both sides by RT. So PV over RT. All right, I'm going to move over here so I have a little more room. So my PV, P is going to be 3. Volume, where do I get that from? Yep, which one? 10, because we're trying to solve now for the ammonia. So this is going to be your 10 that you got from the stoich. That comes down into this problem now. Then I've got to divide this. What R value am I going to use? Right. The one that's associated with ATM is 0.0821. And they've already got us into Kelvin, so I just need to plunk that number down. All right. So as I move through here, I'm going to end up getting my moles. So I'm going to solve for N. I'm going to multiply these, divide by these. That's going to end up being 1.23 moles of what? NH3. Now I need to multiply by the molar mass. So I'm at this point right here. I'm on number 3. I need to multiply by the molar mass of NH3, which is 17.0. And that's going to give me my grams, so 20.8 grams of NH3.
How do you figure out the molar mass again?
I added a nitrogen, which is 14, plus 3 hydrogens at 1 each. That gives me a total of 17.
Thank you.
All right, so let's try to do number 9. Number 9, we're dealing with water vapor. We have H2 plus O2. Oh, wait a minute. Wait, back the train up, Lippy. Wrong equation.
Methane.
Yep, methane. So methane is CH4. Oxygen yields CO2 plus H2O. There's your balanced equation. Okay, so let's see what we are solving for here. We are given liters of methane, and we're going into moles of water vapor. So let's write down our procedure. Procedure number 1, we are going to use Stoich to do what? Right, so liters of methane into liters of water. Then I'm going to use PV equals nRT. So N equals PV over RT. And that's going to solve for moles of water. And that's what they're asking for. So see if you can come up with the correct answer for that. Thoughts?
No. At empty.
Did you get the right answer? Oh, good. Okay.
That's
All right.
not that empty.
So I used my Stoich. I had 10.5 here. And I used my Stoich to come over here and get 21 liters of water. I then substituted that in. My N is going to equal my 1 ATM times my 21 liters. That came from my Stoich, divided by, I look at this, this is ATM, so my R value is 0.0821. Multiply that by my temperature. I've got to add 273 to this, which is 473. Do the math, and there is my answer. Yay or nay?
Yay.
You have 4 problems tonight. I expect those to be done by, I expect your packet to be done up through until your review by Friday, by Thursday, okay? Thursday you have a lab, so bring your goggles.
Tell her and